start off by introducing myself, and I would love for everyone to introduce themselves and tell us where you're from, what you do for work, and maybe what you would like to talk about today with us. Perhaps we can give you some ideas, and I would love to learn from you all as well. So my name is Jennifer Shackleford, and I'm a park ranger at Mammoth Cave National Park in Mammoth Cave, Kentucky. And my position here at the park is actually education specialist. And so what that means is I'm in charge of the programming for the environmental education department. And we work with 31 schools in the area. And we also have thousands of students that come to the park every year, and our rangers take them into the cave and do individualized programming. So we'll talk a lot more about that today. But a little about my background. I used to teach elementary school. I taught school for 9 years before I got the position here at Mammoth Cave. And at first I worked here in the summers as a seasonal employee giving cave tours, and then I would go back in August and teach school. And then in May, when school would let out, I would come back to Mammoth Cave for the summer. I loved it. I loved teaching. So to me, this is kind of my dream job because I get to work with students all the time, but I also get to teach them all about Mammoth Cave as I'm doing it. So I love it. It's a really fun job. And I hope that what we are doing is really valuable. I feel like it is. I feel like we are teaching these students how to take care of the cave, the groundwater. I feel like it's important. So I really enjoy what I do. And I'm going to let Dr. Huss introduce herself, my co-presenter today.
I'm Jeanine Huss. I teach at Western Kentucky University in Bowling Green, Kentucky. And Bowling Green, I guess, is most known for probably the Corvette Museum. And maybe you all saw the Corvettes crashing down into a sinkhole a few years ago. I think that made international news. So either you know us for Corvettes or you know us for sinkholes, one or the other, I guess. And we do have a cave, a Lost River Cave is in Bowling Green, Kentucky as well. But I teach mostly future elementary teachers. And so we often interact with Jennifer Shackleford at the cave, and we bring our elementary students, future elementary teachers out to Mammoth Cave for a day and do activities with her, so that hopefully they'll bring their students back to the cave when they become classroom teachers.
And if you all would please introduce yourselves, that would be wonderful.
Just a minute. I'll just put my video. I don't know if it's,
oh, cool.
An image on it. I think I have to take off that
camping somewhere.
That looks nice.
Yeah.
How can I take off the background? No background. Oh, that's better.
That looks nice too.
Oh, it's my home. We are on holiday, so I'm at home. My name is Zoltan Imach. I work in Faculty of Geography at Babeș-Bolyai University in Cluj-Napoca, Cluj in Romania. It's Transylvania, maybe you know, it's near Hungary. I'm Hungarian, living in Romania and teaching Hungarian students. And besides my basic teaching, which is GIS, remote sensing, and other technical stuffs, I have a course of karstology, as I was as a young man, an amateur speleologist. So I teach karstology in one semester in the second year at BSc level. And during the practical part of the course, we always I'm always trying to take the students to a trip and to some caves. And some of them are liking the cave, others are not. And I always telling them that if just 10% of you will get your child, your family, or relatives to a cave, then it's a success.
Yeah.
So I agree. And it's very strange that many of them don't like to go to trips, don't like hiking, even if they came to geography. So we are always surprised, but not all of them. Of course, there are always fans of such activities, but not all of them.
Mm-hmm.
Well, it's nice to meet you. Thank you for sharing. We have teachers every year that Jeanine brings here that do not like the cave as well. we quite often have some that are very scared. And one of the things we try to do is explain to them, keep those thoughts to yourself when you bring your students here, because we don't want to scare all of your future students, you know, and make them scared of caves. So we try to save them.
Actually, it's a very hostile environment, and during these trips, I take them to a cave which is a show cave, and then to a very extreme cave.
Okay.
Can touch their limits. And I'm always telling them, if I can do it, I'm 60, then you can do it.
Oh gosh.
And they are surprised how we can. So really, they can see I bring them in situations which are uncomfortable, you know, difficult caves, not without light, without you need special equipment and so on. There are always persons who like it and others who doesn't. I can't force them to use this.
Yeah.
Would you like to introduce yourself? We saw your beautiful pictures earlier.
Yeah, hi. So my name is Alina. I'm from Slovakia, like I said, from Košice University, the Faculty of Natural Sciences. I am head of the Department of the Physical Geography, where we have, or the most of the physical geography research is direction cave and karst. So many of us, we are dealing somehow with the karst and caves. In my teaching part of the job, I'm teaching geomorphology lectures, karst geomorphology, and speleology. But on the second hand, I'm studying teacher of biology and geography, so master of biology and geography, and later PhD on karst geomorphology. So I'm teaching also future teachers subjects related to teaching in the field. So this is very interesting for me, and I think it's very important part of the teaching geography, because there are many experiments and many features related to the natures which you need to understand and to see how it works and how it's developed in the field. So I'm doing a lot of with this. Why this session was also interesting for me, not only maybe because of some new ideas on teaching in my karstology and speleology subjects, but I'm also part of the national project in Slovakia, which is dealing with new methods and new methodics in teaching of the geography. And I'm doing there a lot of with this field teaching, or teaching in a field for students for secondary grammar school, and also children. So I'm searching for new ideas what to bring there to the project. So this is the part of my teaching work at the university, and in the field I'm working mainly with the dolines and sinkholes. So Kentucky is very nice and interesting for me, but I've never visited this part of the world. I'm doing with the denudation of the karst landscape, and caving, measuring caves, and doing some hydrology studies in the caves. So it's like everything together. And in my free time, I'm doing the same because this is also my hobby. My husband is also a caver and cave diver, so we are doing a lot of, or we are spending a lot of our free time in caves and karst landscape, I would say. Even now, a little bit, it's a little bit complicated because I have 1.5-year old daughter, but she's going with us also to the caves already. Yes. And I'm also active in European Speleological Federation, like General Secretary. So I'm doing a lot of with communication with the European countries and speleological clubs, and dealing with caving politics, I would say, because it's more job about politics and communication like about caving, I would say. So that's my life. And
thank you for sharing with us. It looks like Philip just joined us, and we had just been introducing ourselves and telling sort of where we work, what we do, and perhaps what you might be interested in learning today from us, so we can try to maybe focus on some of those things. If you'd like to introduce yourself, that'd be wonderful.
Yeah, sorry I'm late. I got caught up in something else. Anyway, I am at the University of South Florida, which of course is a very large karst area. It relies heavily on the aquifer. At University of South Florida, we have probably 5 people in the School of Geosciences that concentrate in karst research. My research is looking at paleoclimate change, but also the human-environment interactions. I have done quite a bit of work looking at different environmental indices, for example, how to measure human impact in karst environments, but also created a hydrological model for measuring the impact of pollution in the area. Finally, I also created an index on sustainability, for karst sustainability. As far as teaching goes, which of course is the subject of today, I teach karst environments to undergrad students, usually once a year to around 40 students, they're seniors. And also I have started to participate in science festivals. In St. Petersburg, there is a science festival that attracts something like 15,000 people. Wow. That's on the weekend. On a Friday, we have something like 1,000 school children come to the science festival. And what I did is the university, the karst research group created a cave. And the cave was stuck in a box in the basement. It was a very large box. The walls were made of fiberglass. And they had some artificial speleothems sticking out of the walls and the floor. So and no one was using it. So I thought, what a great exhibit we could use in the science festival. So we took that exhibit and we dismantled it, and I had my karst students, my undergrad students, actually improve it. So we created 4 different sections, one on prehistoric uses of the cave. So we copied some art from some of the caves in Spain and France. And then we went into the physical environment of speleothems. Then they moved in to the biology, biota that you see in caves. And then finally, the section was on human impact. So vandalism, trash, all that type of thing. So my students didn't just create this exhibit, they actually were tour guides. So each tour guide was actually responsible for one section. So the ones that created this section were responsible for educating the public on it. And then we also had a very big cross-section of karst. So you could actually explain all the different processes in the karst, not just the physical environment, but also how agriculture interacts with the environment, how the urban environment impacts karst. So, that's the kind of education efforts that I've been involved with here in Florida.
That sounds amazing. How large is this exhibit? I mean, how did you all move it, and how much did it cost to make? I'm kind of thinking, wow, that could be something that maybe some of us might want to try to build.
Yeah. Well, the cave itself is about 10 meters long.
Okay.
So it was dismantleable. So we actually had to build the roof of the cave because we couldn't move big plywood boxes. It was impossible. So we just used the shell of the fiberglass, and we put that onto PVC pipes. We strengthened it so that the walls wouldn't flex too much. So then we put it on 2 trucks.
Okay.
So, and we had little alcoves that had like you looked into a side of a cave so you could see the stalagmites. So the little kids wouldn't touch it. They would move past it, or they would have to move around this big stalagmite sticking in the cave or sticking out of the cave. So we had 2 alcoves, one for the stalagmites, stalactites, and also one for the biota. So that's the kind of way we could transport it. So alcoves plus the actual dismantled passages in the cave.
Oh, I know students. I can just imagine how much they would love that. That would be amazing.
Yeah, in fact, we had people go through, kids on the weekend. One kid went through 18 times. We had 2 dogs go through. And many families. It was probably the most popular exhibit. Like when people walk past, you say, "You want to go in the cave?" and you betcha they want to go in the cave.
We have a crawling box or a squeeze box. I'm not sure what you all call it where you're from, but it goes down. I think it goes to around like 6 inches. I of course can't fit through the 6, but we take it out to schools. It's made out of plywood, and we can keep moving it down like 1/2 inch intervals. The students love it. We take it every year to a big festival in Bowling Green, and every time we take it, over 1,000 people will crawl through it. It's pretty amazing to watch them. They love it.
Yeah, we have to fit everybody through. That's the one thing. But we have a smaller entrance, like we put fabric over an entrance and we make it smaller so that people have to almost get down on their bellies. Not quite, but they can crouch very comfortably. The cave's about 1 meter high.
Okay.
And about 1 meter wide. So, and you move from one part section of the cave to another, so they're separated from each other, so you can't see the next section. So you actually have to move from one to the other. And we have artificial lights that highlight certain things. The tour guides have little lights that they shine to certain features to try to educate it. So we had to make sure people could go through in only 5 minutes. Because with so many people wanting to go through, we couldn't have, you could have spent half an hour in the cave easily. But we had to. And the interesting thing is when the kids wanted to go through and some parents didn't, then we actually had a very, very large cross section, which is like 1 meter by 1 meter. And it's held within 2 plexiglass sheets. And so that you can educate the parents about karst while the kids are going through. And during the school day, we can educate all the kids about the karst. So, and no one knows what karst means. Even though everyone lives on it in Florida, you have no idea what it means. So that's one of our jobs, to educate people. And we talk about how people can pollute it. We talk about sinkholes, which is so important here in Florida. The kids made artificial sinkholes in cups. So we could divide up different activities.
That's one of the activities we do is a sinkhole in a cup. We teach that to our teachers. you actually didn't get to kind of meet everyone, but my name is Jennifer, and today Dr. Huss and I will be presenting. I used to teach elementary school, and Jeanine actually teaches to be teachers. She works at Western Kentucky University, and so we work together to teach all kinds of student teachers that are getting ready to go out into the classroom how to teach karst. So I'm going to go on and I'm going to share my screen so you all can see this PowerPoint. Now it does have some videos embedded into the PowerPoint. Today, what we would have been doing if it weren't for COVID is this workshop. We had an hour and a half, and we were going to bring some of our activities and actually do hands-on activities with you all, just like we would do with a ton of elementary students every year. But unfortunately, since we can't do that today, we made videos of the activities that we would have been doing. So let me share this, and I'll show you all our PowerPoint. Let me get back to the beginning. So, are you all seeing? Okay, Jeanine says yes, thumbs up. All right. So we've actually already introduced ourselves earlier, but a little bit about our program here at Mammoth Cave. I'm not really sure the exact date that we started having an environmental education program, but I know it was sometime in the 1970s, just from paperwork that I've found. I'm one of those students that is from the area, so as a little girl, I remember I grew up on a farm, and we had sinkholes on our farm, and I'll tell the truth, I'm not gonna lie. We didn't know better. I remember walking around the sinkhole and seeing an old car from like the 50s or the 60s. And if a cow died, you know, like my dad would throw the cow in the sinkhole. It was the 70s and the early 80s, and we just didn't know. I remember the park ranger coming to my elementary school and talking about sinkholes and how that was bad, and how when you threw things into the sinkhole, it affected the water that you drink. And I ran home to my parents and was like, Daddy, you can't throw any more calves that die into the sinkhole. I'm a product of this environmental education program. So I know it was around in the 70s and early 80s, because I got to see those rangers when they would visit my school. Last year, in fiscal year 2019, we actually worked with over 57,000 students. So it's a big, big program. And once again, I think it's important because we are working with so many students. I hope we're making a difference in their life, just like those park rangers did in my life. I'm sure my mom and dad, I don't know, apparently they believed me, because we ended up cleaning the sinkhole out years later. So it's now a clean sinkhole at my old farm. And I'm going to let Jeanine talk about this because this is so important. It sounds like most of you all, you know, you're working with universities, and so maybe this is something you might want to do with a local cave. So
yes. So I came to Western Kentucky University in 2005. So I've been here for, I don't know, about 15 years or so. And in 2005, it was already established prior to when I got here. So I know it's over 15 years old that my students always came to Mammoth Cave. And at the beginning, I know before I started, students were coming to Mammoth Cave not to even see the cave. They were actually doing a Project Wild or Project Learning Tree training there. And we changed it when I started, and I said, I want to do some like above ground things. So you see us in some of the activities we're going to show you today are some of the above ground activities. And then we spend about half the day, so like kind of like 2 hours or so in the cave. And so that's how we changed the program, is teaching about karst and geology to the future elementary teachers. And we did have a grant for a little while where we actually did some overnight trips. So some students were lucky enough to spend 2 days, and so we were able to see 2 caves during that time as well. And so that made it even that much better.
And in these pictures, if you look at the top left, this is an activity where you give the teachers or the students, if you're doing this with school students, you give them a cup and some rock and some sand and a coffee filter, and they build, and a tube, and I can send the lesson plans to any of you all that are interested. They build a little filtration system, and you walk around with food coloring, and you put 1 drop of food coloring into that cup, onto that rock, just 1 drop. And then they have to keep putting water into that cup and kind of sucking it out with the syringe. That's what she's doing there, until all the green is gone. The green is the pollution. And it takes forever, and it takes a lot of water to finally get that 1 drop of pollution out. And that is an activity we call 1 drop of pollution. So if that's something you're interested in, it really, I think it makes an impact. It shows them how 1 little bitty drop of food coloring can take you 20, 25 minutes of squeezing water and pouring water to get it out. The bottom picture, those are soda bottles, like 2-liter soda bottles, or pop. I'm not sure what you call it where you're from. And one of those is a karst model and one is a non-karst model. And we have the lesson plans to build those. It takes clay, like modeling clay, and some rocks and a little piece of PVC pipe. And on that, we usually either put some food coloring or some pickle relish, like you would eat, on top of each model. And then they're pouring water. So they're pretending that it's raining. And you can immediately see the pollution, of course, go down through that karst model, whereas the non-karst model is not like that. So that's what that activity is. And then the picture.
Oh, I was going to say, Jennifer, that's a really nice one too, because I actually teach in Bowling Green, but we do have campuses in Elizabethtown, Glasgow, and Owensboro also are regional sites. And so we have those models at each of the 4 sites. So students, after they've done it at the cave, we also say, hey, you can borrow these when you're student teaching or become teachers, which is also really nice. And Jennifer's allowed our students to borrow fossils and other things too. So that's like a really great connection for our students, where they can borrow materials to do activities with their students.
So that would be a good thing for you all if you have some funding to be able to loan out that stuff. We have a lot of people that borrow it every year. So once schools find out, oh, they have things that we can use for free, I don't have to go buy those mineral kits to use with my students, they'll just get in contact and borrow those for a week or so. So as we were talking about earlier, we do partner with a lot of local schools. And I really think that one of the reasons we are able to partner with so many schools is because of that partnership with Western Kentucky University. As Jeanine was saying, all of those students that she works with, they come here to Mammoth Cave for one of those teacher workshops the semester before they graduate from college. And so what that means is right before they're going out to become a classroom teacher, they get to come to the park for the day. And they learn about the park, they learn about how we do loan out those things, how we can go into their classroom and do programs or virtual programming. And because of that, when they go out to those schools, they know, hey, we can have these science lessons, and also social studies lessons goes along with Mammoth Cave as well, for free. And so it's really great that we're able to have the workshop with Western. I think it really helps us get into those schools, and the teachers have buy-in. They understand what we're doing because they've been here all day just before they graduate from college. And this is going to be our first video, and I hope that we can make sure this works okay. We had a few snafus the other day, but I think we've got it all fixed. So this is one of the activities, had we been doing our workshop in person, where we would have had a big marker board and let you all tell us animals to put into our shallow sea. And at the top, what you see, that 4-ESS1-1, those are from the next generation science standards, which most of the states in Kentucky, or most of the states in the United States are using those science standards now. So we have adapted our activities and kind of correlated the new science standards with our activities. So let me turn my speaker up so you all can hear this good. And we will let you watch the first video.
And that's going into the historic entrance, which is typically where we bring our students on the Mammoth Cave trip.
Hello, everyone. This is Roderick Davis, Ranger at Mammoth Cave National Park. Today, we're going to talk about some activities that you can use in your classroom. This in particular is called the Shallow Sea Activity, which basically helps kids understand a little bit about the formation of limestone over time. So long ago, before dinosaurs, this part of Kentucky didn't look anything like what it looks like now. We were covered by a very warm, shallow sea, similar to something that you might see, in the Caribbean. Lots of life in that sea. So the way that we would start out with a group of kids is asking them what could have possibly lived in that shallow sea during a period of time. So you just kind of throw that question out there and let the kids begin to answer what they think would have lived in that sea. A lot of times you'll get answers like whales, dolphins. During that period of time, those things weren't around just yet. So you start to listen for other answers. When they start to say things like sharks, and you take your board, take your marker, start down here at the lowest level, and just draw, something that might represent a shark. Okay, and then you continue to take answers over time, maybe jellyfish. So you have your jellyfish here. What that might look like. They may say something about crabs. Crabs like that. So you got your little crabs here. Something like that. Just various fish that they might talk about. So you got your fish. And then, you continue to take those things for as long as you feel comfortable doing so, as long as they are, relevant to what we're studying. Then you talk about eventually what will happen to these things that are swimming around in that ocean. They're going to eventually die. And when they die, the soft parts of their bodies are going to decompose and be gone, leaving behind bones and harder parts of the animal that are calcium based. So those things are eventually, the bones are going to sink to the bottom of this shallow sea and lay on the bottom. And then this process is going to basically repeat itself over periods of time. So eventually you're going to have layer after layer of bones that kind of build up on top of each other over long periods of time. Eventually those bones, because of the new weight of what's on top, there's going to be compaction. These things are all going to squeeze together to form limestone over long periods of time. Now, eventually that warm shallow sea that was covering this area is going to go away. And when it leaves and kind of goes away, we're going to be covered with layers of sand and silt up here, which is basically going to form caprock over the top of these layers of sand, of limestone. So all of this is going to become limestone, and then you're going to have a caprock up here of sandstone, which is basically a great combination, perfect recipe for over time the formation of caves, and what is going to kind of be present before the formation of Mammoth Cave over time. And we can get into a little bit more of that in a different video, talking about how Mammoth Cave was actually formed limestone with sandstone. So this is the shallow sea activity, just to kind of help kids understand how limestone was actually formed over time by these calcium-based bones from these ancient sea creatures that we got long ago. Thanks.
So with that activity, if we were in the classroom, we would actually have the students come up to the marker board or whatever type of board they're using and draw different animals onto the board. Virtually, since we've been doing our virtual classrooms due to COVID, one way that you can still do this and make it where it's more interactive is you can have the students use a notebook of their own or a marker board of their own and have them hold it up to the camera and show you what they're drawing. It just makes it a little bit more where they're getting to be interactive. But that's just one of the really simple activities that we do starting with preschool students. We want them to understand that in this part of Kentucky, you know, years ago we had that ocean, there were things that lived in it. Of course, it's not here anymore. At that point, we're also, especially if they're older kids, we're going to go into, you know, how Kentucky wasn't where it is right now. You know, we were below the equator, and we'll bring in more of those things.
Well, and I was going to mention, Jennifer, that they just found, Mammoth Cave found the shark fossil this summer. That was really exciting as well. So even though people might not think sharks are in Kentucky, there is proof now in Mammoth Cave itself. They found parts of a shark. And I can't remember how old it is, so I won't quote that part, but that was exciting.
All right, I am trying to get through, not wanting to go to the next slide. I told you all we might have a few snafus with this, so here's what I'm gonna do. I am just going to bring up this part and get back down there. Sorry, you all. My mouse is, I'm trying to find it. Okay, so
There you go.
there we go. All right. It's not bringing it up as large as I wanted to.
Well, can you go down to the right-hand corner? There we go. Oh.
Well, overnight teacher workshop. That's what I want to talk about.
It doesn't want to go to the next slide.
Okay.
That's
Sorry.
odd.
And of course, I see that my supervisor is on here. Hello, Mr. Trimble. We all introduced ourselves earlier.
I'm jumping in and out. You're doing great. Thanks.
Having some technical difficulties. Okay, can you all see this okay? I know it's not as perfect, but for some reason it is not wanting to show it.
Jennifer, can you click on the bottom where you can also click on the full screen thing? Right where it says notes on your, oh, I don't know. Now I can't see it.
It's going to make us watch that video again. I was trying to get
Yeah, okay. Darn.
So.
All right, we'll do this for right now. Maybe it'll behave after the next video. Oh, there we go.
It's fixed. So I'll let you talk about the overnight teacher workshops that we've been doing.
All right, so a few years ago, we were able to get a grant to have overnight teacher workshops. So that was actually a 2-day workshop where our future elementary teachers came, and we actually did the overnight workshops 3 times a semester. So we had 3 different groups of students, and typically, I can't remember the numbers, but I would say under 30, yeah, like 20, 24 students would come and spend the night, and we would see the historic cave on one day, and then Onyx Cave, I can't remember. Onyx Cave, Great Onyx, thank you, the other day. And so you see that our students in Great Onyx were able to wear helmets, which they thought was really cool. That was really exciting for them. And she's up close and personal to looking at gypsum, which was also really exciting for students to be able to see the gypsum up close and see that part. And one thing on the right side around the table, you'll see the most expensive part of the overnight trips is definitely the food. And we serve them breakfast, 2 lunches, and a dinner. So that was the most expensive part, but we were very lucky to have the cave researchers. We were able to use the existing structures that they have and spend the night there. They had bunk beds at the Cave Researcher Foundation place, and so our students were 4 to a room in bunk beds, and we used their facilities for $10 a night, which definitely saved us some money on the grant. So our students were able to come away with a rock kit, a mineral kit, some magnifying glasses, and some really great historic maps and maps of Mammoth Cave. And I can't remember the other materials, but I know we gave them some other materials that we used during the workshop, and then after the workshop they could use when they became teachers.
And this year we were very lucky to receive some funding from an insurance agency. Actually, it was given to our friends group at Mammoth Cave so we could hold some more overnight teacher workshops. Now we decided, since we're doing the day workshops for Western, that we would use that funding to hold teacher workshops for any teacher that was interested. So we had teachers that had been in the classroom 2 or 3 years, all the way up to teachers who had been teaching for 20 years. And we were able to hold 3 of those this summer. So that was really exciting to have those teachers come here. Because of COVID, we had smaller workshops. We only had 10 teachers at each workshop. And that was because there are 10 rooms at that Hamilton Valley Research facility. So each person could have their own room. And we could social distance. But we're gonna be able to have some more of those this October. And if that's something you think you might be interested in, if you can work with one of the local caves where you're at with your university, I'd be happy to share the plans of what we do over that 2-day workshop, those lesson plans with you.
And I will say, someone mentioned earlier how students were scared of going to the cave, and we don't crawl on these cave tours. Future elementary teachers are not into crawling, and I can say honestly that I probably would not be into crawling either. But usually they're okay with going into the cave, but I will say the cave crickets are maybe the thing that students fear the worst because they look like spiders, and a lot of my students are afraid of spiders, unfortunately. So we try to prepare them for cave crickets and then tell them, you know, if you're really loud and you know, afraid of them and screaming, they'll jump on you. So it's better to be quiet around the cave crickets. And typically they do a good job with the cave crickets. There's only been a few incidents. I know one cave cricket jumped on a student once and she screamed bloody murder. But beyond that one student, we've had really no incidents with cave crickets.
This next slide is talking about the on-site visits when those teachers go back to the classroom and then bring their students here to Mammoth Cave. And every year, normally, we have a few thousand students that visit the park, and it's more than just a cave tour. When you visit through the Environmental Education Department, we do above ground studies as well that focus on things like karst and water quality. So if you look at this picture on the left, these students are at Sloan's Crossing Pond, which is an area here at Mammoth Cave, and they're doing a macroinvertebrate study. And so we'll take the students over there, we'll do a dissolved oxygen test, pH testing. We let them look at all the different things such as dragonfly larvae that are in that water. We also have a citizen science project. It's a national citizen science project that pertains to those dragonfly larvae. So we teach the kids how to do, you know, real life science. They love it. We talk clean hand, dirty hand method. They have to get those dragonfly larvae, we collect them, and then we ship them off to a lab every year. and they're freeze dried and ground down, and they tell us the mercury levels that are in the area here at Mammoth Cave. So it takes about a year to get those results, but whenever we get the results, we send those to the schools that have helped with that project, so the students can see that the citizen science that they came to the park and actually participated in is important to us, and it has real results. And on the front of those citizen science printouts that they send us, those reports, every year they use a picture such as this one. So it's also kind of fun for the kids to see, oh, I have a picture on a big national report. The picture at the top, they have a little pipette. Those young ladies were over at the pond. So there's probably some kind of cool aquatic worm or something in there that they're looking at, I would think. And at the bottom, they're over in our picnic area. We have a building called the Earth House that is filled with activity tubs with all kinds of lesson plans that we can use with these students. And once again, we are happy to share any lesson plan we have with you. I can email those to you. But these students are doing an activity from Project Wild, and it's about camouflage. So they are learning about how different animals and insects can camouflage themselves. And all those national projects like Project Underground that deals specifically just with cave and karst areas, you can get training on those very inexpensively. I think, Jeanine, we can train people as well. So if that's something you're interested in, I've never done a virtual Project Wet or Project Underground training, but I'm willing to try it. We are certified to do those, and we can certify you all to teach Project Wet or Project Underground if it's something you're interested in. This next page is something that we send out to the teachers, where they fill out exactly what they'd like us to work on that day when they come to the park, or when we go to the school, or when we do a virtual classroom. So for example, since everything is virtual this fall for us, we'll be working on geology and karst with Mr. Davis and Miss Hensley here in a few days. And we will be talking about, it says he's wanting us to talk about developing a model describing ways the geosphere, biosphere, hydrosphere, and atmosphere interact. So for that, we will probably do an activity with the students virtually that has to do with the carbon cycle. And that's also from one of those curriculum projects. They throw little cubes. So we'll have to come up with a way to do that on the computer with them. But I think another reason we have really good buy-in from the local schools is because it is curriculum based. We let those teachers tell us what they want us to do standards wise, and then we come up with an activity that meets those educational standards. And Jeanine, I'm going to let you talk about sandstone rub and acid drop.
All right, so when my students come to the park, we typically do the sandstone rub and acid drop activity. And before we come to the park, so I mean, and I assume this is true for our K-12 teachers as well, we often prepare them for what we're going to do at Mammoth Cave. So before we've visited Mammoth Cave, we have actually looked at minerals, and we have looked at rocks and talked about the 3 types. And I've also talked about the 3 main types of rocks found in Kentucky, so that hopefully when we get to Mammoth Cave, it's not unfamiliar and like foreign to them. Hopefully they know a little bit. So the sandstone and limestone rub, we don't do before we go to Mammoth Cave, because I know we're going to do it at Mammoth Cave. And so really we're talking about chemical weathering and physical weathering with this activity. So we take 2, well, maybe I shouldn't say any more, and we watch the video first, and then we'll talk more afterwards.
All right, so today we're going to be talking about the activity called sandstone limestone rub, and we're going to do a little bit of an acid drop here in just a second to talk a little bit about physical weathering, chemical weathering, and how that relates to cave formation over time. So in order to do this activity, have a few materials scattered out here. You need a couple of pieces of sandstone rock, a couple of pieces of limestone rock. We have just a basic shell here that you can find about anywhere really. And this is some hydrochloric acid. You can obtain this from with a local university near us, or you can also, if you can't get your hands on some of this stuff, you can also use just a vinegar type material that would allow the same to take place. And then you have just a regular plastic microwavable bowl of some kind. The darker colors work best so that you can see a little bit more of what's going to happen in just a second. So we'll go ahead and get started with this. First of all, we'll start by taking the sandstone samples. Pick those up, and we would ask the kids to just kind of feel those, maybe identify some of the properties. They're probably going to notice these are kind of scratchy or a little bit of a rough surface there. And talk about how sandstone weathers pretty easily physically by rubbing together. So we would have them take these sandstone rocks, hold them over the container that we have here, and then we would instruct them to rub those together for just a few seconds. So I'm going to go ahead and do that. The scratch marks that we have, and a little bit of sediment that'll come off on your finger there. And then inside the bowl, you can see the small sediments of sandstone that have weathered away. So sandstone is very susceptible to physical weathering over long periods of time. Then we would take our other samples of limestone and again have the kids maybe identify some of the properties. It's not quite as rough as the sandstone, a little bit smoother, kind of bumpy, jagged edges sometimes. But then we would instruct them to do the same thing. So we would take these and have the students again rub those together over the bowl. And you're going to be able to see maybe a few little sediments flake off, but by and large, limestone does not physically weather anywhere near as easily as sandstone does over time. So that's kind of the rub part of the activity there. But then we move into talking about how does this relate to cave formation? Well, in the earlier video that we talked about with the shallow sea activity, we talked about how ancient sea creatures, when they die, the soft parts decompose, decay, the bones are left behind, and they eventually stack up on each other until they're compacted to form limestone, which is this. Now, when that sea went away, what was left behind were layers of sand above that, which eventually formed sandstone. So how that relates to cave formation is you can take a piece of limestone, kind of put that down on the bottom right there, and then imagine the sand on top like that. And that's kind of what we have in this area at Mammoth Cave is we have a limestone base or foundation and then a sandstone cap rock over the top of it. Now, the way that works with cave formation is the sandstone acts as kind of a roof over the top of the cave. So if you think about your house and the shingles on the roof, that would be what your sandstone is for the cave, essentially. So next we would do the acid drop to talk about how these different rocks react to carbonic acid. So we would put that in this bowl, the sandstone first, and have the students put that in the bowl. And then we would take the dropper, just a little bit of acid up inside, and then drop that on the top of the sandstone and have the students observe what's happening. So when you look at the sandstone there, it just looks wet. Nothing really is happening. It's almost like if you were to drop a few little drops of water on top of it. Nothing's happening. It just can kind of run off. No big deal. And if you think about that with regard to the cave, if we put that back on top like that, you can see how the water on top is not going through. But when you take a piece of limestone and you do the same thing, something very different happens. There. And you can kind of see how it starts to bubble up, almost like putting peroxide on a cut. It has an odor that comes off of there, indicating chemical reaction taking place. Now, over time, that would eat away at that limestone and form passageways through the rock. So the way that happens is when it rains, rainwater falls down through the atmosphere, picks up little bits of carbon dioxide in the air, forming a very weak carbonic acid. That carbonic acid, when it comes in contact with sandstone, doesn't really have any effect. Sandstone does not weather chemically very easily. However, when that comes into contact with limestone, it begins to slowly dissolve and eat away at the limestone, forming gaps, passageways, cavities inside that limestone rock, which eventually widen out to form cave passageways. So that's kind of how Mammoth Cave was formed over time. The water is not able to get in, straight above, but if it gets in sideways, or if it finds a crack in that sandstone cap rock and can get down to limestone, then that's where those cave passageways are formed over time. A way that you can kind of relate this to something that kids might understand better is your teeth. Your teeth are calcium based in your mouth, bone, similar to the way that limestone is a calcium based rock from the shells and skeletons of ancient sea creatures. If you drink a lot of soda, that soda has carbonic acid in it, very similar to what impacts the limestone rock. So if you drink lots of soda, that carbonic acid is going to eat away at your teeth and form a cavity. A lot of times we joke and say that you have a cavity. It's a little cave inside your teeth, hole and opening, which is formed by carbonic acid eating away at the calcium-based tooth in your mouth. Similar to this acid eating away at the limestone here to form cave passageways. We talked about earlier how this limestone rock is essentially made of bones and shells of ancient sea creatures. So when you think about this shell, since this limestone rock is basically made from this and bones like that, what we would expect to happen if we put just a little bit of acid on this is the same thing that happens to your limestone. So you see the same kind of reaction. You see the fizzing, the bubbling, the smell. So it's just showing evidence and further proof that this, again, is a calcium-based rock made from shells and bones of ancient sea creatures. So this activity is just meant to talk about how Mammoth Cave was formed through chemical weathering over a long period of time, how the sandstone cap rock kind of keeps the water out of the cave in certain places where you have dry cave, other places where the sandstone cap rock isn't there. You see quite a few more formations, but because the cave is covered with sandstone cap rock, we have the longest cave system in the world for the Mammoth Cave. So that is the sandstone limestone rock acid drop activity.
Sorry about the insects.
All right, so one other thing I wanted to mention on that, typically with my students, we also pull out shale for them, excuse me, and we look at the 3 types of rocks and see if they can identify the 3 types just on color. And we talk about why looking at the rocks, excuse me, color is not a good indicator of what type of rock it is, especially since we've already looked at those 3 types of rocks in the classroom before we go on the Mammoth Cave trip. And another thing I wanted to point out, so doing the acid drop helps us realize what type of rock it is, or doing the physical weathering activity also helps us identify the type of rock it is. But before we go to the cave, we also walk over to where a disappearing stream is. So one thing we try to do also with the students is talk about indicators of caves. So we look for sinkholes, we look for disappearing streams, and those type of things on the way down to the cave so that they understand. And we also typically point out sandstone as well because it's beautiful in the sunlight and sparkles, so it's like pretty easy to see. And then you have to think about, oh, sandstone's on top, and then when we get to the cave, oh, we're inside of limestone when we go into the cave. So that also helps them. We've looked at some things beforehand, and then we're going to go see the cave and, you know, actually experience that as well. So hopefully that's making some good connections for them with the activities labs that we've done prior to going into the cave.
The next pictures are showing our week-long summer day camps, and to me, these are one of the most exciting things that we do here at Mammoth Cave National Park in the Environmental Education Department. I love these camps. The pictures that you see, the one on the top, the students are actually inside the cave, and they have clinos, you know, inclinometers, they've got their compasses, and they are surveying inside a portion of the cave called Gothic Avenue. We take them to a little USGS marker in the cave because, of course, we know exactly where that is above ground, and that's where they begin the surveying. We break them up into surveying teams. They put flags out. There's one person that is sketching. So they are actually doing real cave surveying. Of course, it's been surveyed plenty of times before, but this is a way for them to get to experience that, do some math, learn about what surveying is like. And then that afternoon, we take them above ground. So this is the same group of students. Normally our camps have around 25 students each, and we break them into maybe 5 different surveying groups, and we start them at different areas of Gothic Avenue. Then we go above ground with our big long tape measurer, and once again, she's got you know, her compass there, and they survey the exact same area above ground. So it's so interesting to them. They get to look and see, oh, in the cave, there was some really cool vertical passage. There, you know, was a pit dome going on in that area. And above ground, there was a sinkhole. So they can see the relationship between the above and below ground. It's really interesting. We also have a store here at the park that used to have gas tanks, and we go directly underneath that store. So used to, we went underneath those gasoline tanks, you know, of course, we're 100 and some feet underground, but we could talk with the students about that. They've since been removed. The store no longer sells gasoline, but we still bring up with the students when we're above ground. Oh, do you guys remember who surveyed, you know, flag G1 to G2? And you know, what's above you? Here we are, we're at the store where the gas tanks used to be. What might have happened if there would have been a leak a few years ago before they dug those up? So it's real life. The kids really enjoy it, and I think they really like seeing the difference between the above and below ground. The most fun part for them of this is the bridal altar is an area in Mammoth Cave that they end at. That's where we quit our surveying. And above ground, the bridal altar is right underneath one of our campground sites. So it's really fun in the summer when we're doing these camps. The students get to share what they've learned with the visitors if they're at that campsite that day. So we kind of walk up to the edge of the campsite, and the kids are like, oh, we're above the bridal altar. It's beneath our feet, 100 and some feet below us. And then the visitors are like, what is this group of 25 children doing beside my campsite? So that's a fun thing that we enjoy. And these camps, once again, they're with the local schools. So we have all kinds of really cool curriculum. They are all based on karst, groundwater. All week they are immersed in the resource. They're here for 8 in the morning until 3 in the afternoon. Another really fun thing we do is we invite the parents out on the last day of camp in the afternoon, and the students get to teach the parents about some of the things that they've learned. Some years we let the students lead a cave tour. That's interesting. And they get to tell their parents, you know, about the different things inside the cave. I'm gonna let Jeanine talk about Secret Sink.
All right, so Secret Sink is an activity from Project Underground, but basically what you're doing is looking on the left side, you're actually looking at a cave in a river, and you're trying to decide, a sinkhole, sorry, in a river, and trying to decide where all of these things on the right side should be placed. So you're actually building, you know, a site. So you have to think about in the Rick's talk yesterday talked about the highway and the railroad and in the importance of, you know, sometimes things spill from the highway. So you have to think about, do you want the highway really close to the sinkhole? Probably not. And so, you know, you just have to allow students to place the items first, and then you talk about the positives or negatives and what might you have to do to protect the river or the sinkhole from these things if you place them too close to the sinkhole or too close to the river. And so you can talk about point, non-point pollution and runoff and those type of things, and what might be coming from the tobacco field or the bleach factory, and how to protect your natural resources, basically.
And this is an activity that can be completed virtually very easily. You just have to send these documents to the teachers ahead of time. And then, of course, they would pass those out to the students. So virtual classrooms, we started a few years ago having virtual classrooms. And now, due to the COVID happening, we are going to be doing virtual classrooms for the next few months until things get better, because the school systems in the area will not allow visitors. And a lot of the schools are actually doing virtual where the students are at home. So because of that, instead of going into the schools this fall, we are doing these virtual classrooms. So that's a picture of me sitting in front of my computer. It's actually where I'm sitting right now, but you all are seeing Mammoth Cave because I have a green screen behind me. But I do keep here at my desk, I have limestone, I have some fossils, here's some crinoid stem, I've got acid. I keep all of that here so I can show those things to the students, and you can see on my computer screen. This was actually a middle school class in another state. The picture at the bottom are students from South Dakota. So on Mammoth Cave's website, we advertise that we do free virtual programming, and quite often I'll get an email. They can click on the link on our website, and I'll have a teacher email and say, hey, I'm in Canada. We did a school in Canada last year, Hawaii. About 2 months ago, I had a school in Honolulu contact me. They were doing a summer school program, and I got to work with a bunch of kids from Hawaii. So they'll get in touch, and then we'll do that virtual programming. And it's inexpensive to begin. You don't have to have fancy things, just a webcam. And if you do have a green screen, it makes it a lot easier, because when we're doing these programs, we can switch the pictures behind us and explain things. So that does help. And Jeanine, I'll let you talk about karst, non-karst some, and then this has a video that we'll show in a minute.
All right, so earlier in our talk, we showed you those 2-liter soda bottles that were the karst, non-karst models that are easy to make and replicate. This is a fancier model that costs a lot more money, which is why we don't send those out to our that's why we have the cheaper versions to give to our students to use. But one thing we typically talk about is, especially where most of the teachers will be teaching, they will be living in a karst area. So that's really important for them to think about that this is the land that they live in, but then also to compare it to the non-karst system as well, which part of Kentucky is non-karst. So to think about how pollution and how water travels through both areas, and typically we talk about Glasgow and how quickly water from Glasgow moves and goes to Mammoth Cave. And I don't know the distance from Glasgow to Mammoth Cave, but Jennifer can tell us that, but it goes very quickly in a karst area. And then we also talk about how slowly in a non-karst area, if you want to clean the water, or I mean, typically in a non-karst area, water is cleaned really well from a non-karst area because it's traveling so slowly through the karst, the rocks and the things underground. But in karst, because of the sinkholes and disappearing streams and things like that, water travels very quickly through a karst area and gets into the water table much quicker that way. So we kind of compare the two and talk about even how your water bill would be very different in a karst, non-karst area, and also why polluting in either region is not good, but especially in a karst area, why pollution on top can affect what's happening below in the karst region.
So this video is Ranger Chris, and as Jeanine said, these models are pretty expensive to purchase, but they are really great to take out to schools and quickly show the students the difference in a karst versus non-karst area.
So here we have a groundwater model, and this groundwater model contains two sides. On the left-hand side is the karst groundwater model. On the other side, we have the non-karst. And so we're going to introduce about a liter of water into the system to establish our water table. And we'll simply do that by inverting the model on this side. And as that water trickles in, you'll notice that the sand on this side begins to get wet, and the water will slowly seep across. So now that we have given the water a chance to settle in, you can see on each side where the water table is holding. It's a little bit more difficult on a non-karst side to see exactly where the water sits. There's a lot of moisture in the sediment, but the bulk of the water is settling down. However, on the karst side, it's very distinct where the water is in the empty spaces. Now, this is a pretty neat visual way to kind of see the difference between the karst and the non-karst. But this is a great way to also demonstrate what happens when pollution is introduced into these systems. Now, pollution anywhere is bad. However, there are a lot more immediate effect pollution in the karst system. So the first thing we're going to do is introduce some chemicals into our underground tank. A lot of things are stored in tanks in the ground. We're going to do that using blue food coloring. All right, so I'm going to inject the blue food coloring into the underground tank. Let's see it working its way in. And the tank is kind of leaking in around it. And so we have an obvious leak in our underground tank. So what effect does that have in the groundwater? Well, obviously it pollutes the groundwater, but how quickly is really the thing that we're concerned about. So you'll notice we have a pumping well here, and it's very common when we pumping water from groundwater anywhere in the country. And so as we begin to pump the water out of the ground, it is going to draw from water on this side. And that drawing of the water is going to pull this pollution down and across, but it's not going to do it very rapidly. This is a slow process. And you see it slowly starting to work its way across. But I can pump and pump and pump on this, and it's still going to be a very gradual process of this pollution dispersing. And so you might get by with the pollution occurring in a non-karst area and it not having an immediate impact on the wells where the water is being pumped out or anything else down around the
water table because it takes so long for that moisture to get through the densely packed sediment that you have here on a non-karst area. However, if this were a karst area, the results are much, much different. So we're going to introduce some red dye into the karst side. Now, here in this area, we do have a karst system. And so we do have a lot of these sinkholes. You do get agricultural runoff, you get industrial runoff. So there is always a likelihood of pollution making it into a sinkhole. And you see here where I'm adding it into the sinkhole. We're going to add some water on top of that because when rain occurs, it does wash the sediment down into these sinkholes. Unfortunately, in karst areas, a lot of times people use sinkholes like a dump to get rid of stuff. And you can see very quickly how all of that red dispersed throughout these cavities, these empty spaces that are underground in a karst system. Now, if we were to pump in the well, and we saw how long it took pumping over there to really get the blue to move, with a karst system, once you start pumping, it's almost instantaneous. You see the reds pulled over, up the well, in just a matter of seconds. That pollution is coming right back out the well into a household or a business or whatever it is that is extracting water from this underground system. So even though pollution is a bad thing to have anywhere, the impact of pollution in a karst environment versus non-karst has a much quicker turnaround and more immediately impactful.
All right, and typically, I will say that typically water travels in miles per hour in the karst system and centimeters per year in the non-karst system. So that kind of also helps you think about how quickly it's traveling.
The students love getting to help and pump, by the way. Anytime you can let them be involved like that, I think it makes more of an impact. So these are just a little bit of stats about our program for this fiscal year. Beginning in October last year, we actually went into school systems and did 986 programs. And one thing that we really think is important here, and that I suggest if you are going to go into schools, is if possible, go into an individual classroom. That was 986 homerooms where we only worked with like 25 to 30 students at a time. This was not us in a big gymnasium with hundreds of students. We have one ranger to approximately 20 to 30 students in that classroom. So they're getting hands-on, you know, that one ranger to only 20 some students. Our virtual numbers are actually way over that. Since I've made this slide in the past like 2 weeks, we've now worked with over 1,000 students just since this all kind of began a few months ago with COVID. We did do some workshops with Jeanine in the fall. And so we worked with 50 students from Western. We had 2 different workshops this fall. And then this summer, we worked with right around 40 teachers during those overnight workshops that we did back in July. And on our website, this is the link to look at every bit of our curriculum that the park has developed over the years. So we have karst curriculum for lower elementary, all the way up through middle school. We also have a paleontology curriculum. We have a fire curriculum, which talks about fires and ecosystems and the importance of prescribed burns. People can also click on professional development, and we can provide those workshops like Project Wet, Project Underground, which focuses on caves, and then the distance learning. This is how they sign up for those, is by clicking on that. But this PowerPoint is available for you all, so you can look and be able to click on that curriculum and look at all that and print it off if you'd like it. But once again, all the things we've talked about today, if you email me, I'm happy to send you any lesson plan that we have. We probably have over 200 lesson plans that we can do, that we have typed up and little tubs made. Here's the link right there for all of our material, and this just shows the different curriculums that we have. So K through 8 with karst, and then the paleontology actually goes a little bit higher than that. Let Jeanine talk a little bit about this because she's actually a member of the Friends of Mammoth Cave. Or, actually a board.
Yeah. So there are 2 organizations that work really closely with Jennifer's group at the environmental ed. And the Friends of Mammoth Cave National Park and also the Mammoth Cave National Park, sometimes, especially when you're working with government agencies, you need to funnel money differently. So truthfully, like the Friends Group and the Mammoth Cave National Park Association are able to move money back and forth to her easier, especially food and things like that. But we also, both groups also donate, and her rangers are getting laptops this year so that they can teach virtually from their houses or from National Cave to the students. So they're still going to do those virtual field trips instead of in-person field trips. So that's a really nice partnership between these nonprofit organizations. And the National Park Association gave students the Journey to the Bottomless Pit, which is about Stephen Bishop. Was that to the teachers this summer? I can't remember, Jennifer.
No, they actually gave every 4th grader from local elementary school, each 4th grader got their own copy of that book. And that's, some of the 4th graders are in this picture, and they are doing the Sandstone rub acid drop activity right there.
And that's a really great book about one of the early cave guides. He was actually a slave and received his freedom towards the end. But it's a great book about a slave that actually discovered quite a large part of Mammoth Cave, and he actually drew Mammoth Cave from memory in a hotel room outside of Louisville because he knew the cave so well. He could draw it, and it was very accurate. And so that's one of the maps that we've typically given our teachers on the overnight trips, because it is like a historic map, and also this book goes really well with that map as well, so that they are learning about African Americans, they're learning about slaves, and they're learning about early tour guides.
And this last picture, this is some of those summer camp students. This is when we were getting ready to go down into the cave last year. You can see there's Broderick, Ranger Broderick, that's me right there. And we were getting ready to go down and do some crawling through some smaller passageways and let the kids do some mapping down in that section of the cave. And then this is us out hiking. So once again, we really enjoy immersing the students in the resource, letting them do all these hands-on activities. So I'm going to let you guys ask questions if you have any. And I'll quit sharing my screen.
I have a quick question. How do you find the student interaction when you're doing these virtual classroom activities?
It depends on the age of the students. This summer we did a virtual camp in June. It was every Thursday in June with lower elementary students. And truthfully, each week there were 2 or 3 kids who I don't know that they ever really paid attention. It was kind of funny watching them up at the top of my screen. I would see them. One of them had an office chair in his dad's office, and he would spin around. And one of them fell asleep 2 or 3 weeks, even though we really did try to make them interactive and fun. With the older students, I think anywhere maybe from 5th grade up, they actually go really well. The students ask a lot of questions. We have the teachers and the parents, we ask them to have marker boards or paper in front of them. So we do a lot of things where we'll have them draw things and try to keep them more interactive. Sometimes like Jeanine and I are actually doing one soon with a group where we're making we're making speleothems. We're having them get string and jars and baking soda. And of course, you know, it takes a few days for those to develop. But we're going to do that with them, you know, at that time, have them make their super saturated solution of the water and the soda and stuff. So if you can keep it where they're doing something, they go well. But with the younger kids, yeah, it's kind of funny. Like I was sitting here, you know, talking with them, and we were actually dressing up a ranger as a beaver to do an adaptation activity called Build a Beaver, where you put goggles for a clear third eyelid, and just things like that, flippers onto their feet for their webbed feet and all. And I had one or two kids that were, you know, just conked out asleep. So it's harder with
Yeah. Do you have like any cultural context to any of this? Because obviously we have visitors from Europe, and there may be differences in how people perceive karst, in knowledge that they get taught at schools. So, you know, I imagine this changes dramatically where you are.
Yes, I haven't really kind of studied that, but I would think it would. I know around here with us, as I said earlier, you know, culturally around here, you have to be really careful how you talk about things, because we don't want to offend those parents. Like my dad, I remember my dad getting mad when I came home talking about throwing the cow into the sinkhole, because he felt like somebody was, you know, trying to be his boss and it was his land. So I feel like culturally with us, we have to be really careful how we talk about that. We have a cave that was broken into here at the park a few years ago, and some local people broke off a lot of formations and went and tried to sell them to local stores. They ended up going to federal prison because that's against the law. But we want to teach the students about that, and that you don't do that. You don't bother things. You don't steal stalactites or take the Native American, you know, the paleontology, those thousands of year old things. If you come upon a site outside, you leave those. But we have to be really careful around here about how we do that, because we might be talking to the nephew of that man who was in prison, you know, for stealing those. So as far as us, we just try to, I don't want to say tread lightly, because we do want them to understand it. A part of, you know, our job as the Park Service, our mission is to protect and preserve. So we're teaching them to protect and preserve the cave, but we just watch how we say it. So when, you know.
Well, and sometimes I know in the past people have also asked you not to talk about evolution or like how old the cave is, which you would think is not controversial. But if they're, you know, fundamentalist Christians or whatever, they don't want to say how old the cave is because it's against their beliefs. So that's another thing where it's a little bit difficult to talk to students. And I don't know how Jennifer approaches that one.
Actually, what I do is I say, according to the scientists for the National Park Service, or according to scientists at Mammoth Cave, or according to geologists, that sea was here approximately 350 million years ago. So I try to make it where it's not personal, so they don't want to like get in a fight with me, the teachers or the parents on that trip. So I say, according to the scientists. And it still happens occasionally. You have people who want to kind of fuss with you over it and things, but it doesn't happen too often, but it happens. I'm sure you all have ran into that as well.
Yeah. I was just, as no one else seems to be asking you a question, I imagine the physical environment makes a big difference. Here in Florida, we're as flat as a pancake. You don't really see caves. If there are caves, they're flooded. You know, with the highest elevation is like 245 feet. And where we are, maybe the highest elevation is like 50 feet above sea level.
Oh, yeah.
So we see sinkholes. That's about it. Sinkholes in the aquifer. That's what's important to us. But I imagine other places, like obviously Mammoth Cave, but in Europe, Slovenia and that, I'm sure the caves are the ones that are of most interest to the schools and the local people.
There is a really nice, in the exhibit area now at Mammoth Cave National Park, there's a beautiful picture, a mural of the sinkhole plain along I-65. And that's really neat to show the students because truthfully, I drive it often. And when we go to Mammoth Cave, we drive right by it and you don't really see it, but the mural shows it really well where you can actually see the sinkholes. Yeah. So that's important for them to realize, oh, there's all these sinkholes, and we talk about why there aren't rivers necessarily visible in that area. And, you know, there's a lot of cattle in that area. So you also have to talk about how are cattle getting, you know, water to drink if there's all these sinkholes. What do you have to do to allow cattle to drink in this area?
Mm-hmm. Yeah. Yeah, there's one other thing I would mention that's, I think, throughout the United States. It's something called the Great American Teach-In, which would allow parents who have some kind of profession related to karst, maybe geoengineers. I go in to talk about my research and things and bring in my little cross-section of karst. That's one way that cavers, you know, could potentially go into the schools and talk about, you know, to their local school. It's usually the parents of the kids that go in. So that may be another way that maybe this could be something that could be sent out to the caving community, some of your, like your modules, something that their parents could actually explain to their local school.
Yeah, we would love to share that. What is the group called again?
It's not a group. I think it's just a national day. It's called the Great American Teach-In.
Okay.
I've done it in Florida to some of, you know, to my kids' classes or my, you know, my children's, gone to their schools, and you spend like a half a day there, and you may talk to 8 different classes.
Okay.
So, and you may therefore meet a couple hundred kids, and you talk to them about it. But you get, you know, all different types of people from different professions, firemen, police officers, whatever. So, but you know, a caver could go in and talk to the kids about their local area.
Awesome. Do y'all have anything else to share? I think we're actually out of time, I guess. So I hope you all enjoyed it. If you have any questions about any activities, I'd be happy to email you lesson plans. Like I said, we have quite a large bank of lesson plans. So if there's something in particular, if you have a middle school group or, you know, you're working with a certain age group, I'd be happy to share anything we have. And if you all have something, you know, that you think of that you think would work for us to go into schools and share, please let us know. Email me, and you know, we will use that information as well.
Okay.
Thank you very
Very
much.
much.
Very interesting.
All right, thank you.
Thank you very much. It was
Have a
beautiful.
Yeah, bye. Thank you
Bye.
for attending.
Okay, bye-bye.
Bye. Thank you.